Dear friends, very good day to all of you and welcome back to another session on engineering system design. In the last lecture we discussed about the integration and qualification methods, the last stage in the design of engineering system, where we look at the integration issues as well as the qualification of the system. Basically we discussed about various methods of integration, that is the bottom up approach or top down approach or the big bang approach normally used by software industries. And then we looked at the procedures for component level integration as well as the subsystem level integration, what we do when there is a fault in one of the systems. So what should be the procedure, how do we actually look at the impact of these faults and then redesign or change the specification of the system to meet the present status of those components or subsystems. So that was about integration of engineering systems. Today we will look at the qualification aspects. We briefly explained about qualification, what do you mean by qualification, and what are the various stages in qualification, like verification, validation and acceptance, and we discussed about those top level cycle and the bottom level cycle, or the higher and lower level cycles of qualification. Today we will go into the details of this qualification procedure, what kind of procedure to be adopted and what are the different kinds of acceptance test, and how do we actually ensure that the customer accepts the system, and what are the process by which we can do the testing in order to make sure that that system performs as per the requirements of the customer. So first of all let us recap the qualification procedure and what is qualification. So as we discussed, it is the process of verifying and validating the system design and then obtaining the stakeholders acceptance of the design. So basically we need to verify and validate the design and to ensure that it actually meets the requirements of the customer, and it involves the verification, validation and acceptance. So as we discussed in the previous class, verification is basically to verify the developed system with respect to the specifications we identified at the design stage. Validation is ensuring that it meets the requirements of the customer in terms of the conceptual validity or the design validity, and then acceptance is basically we give the system, the complete system to the user, and the user conducts acceptance test and then accept the system. So these are the three stages through which the qualification process goes through, and then we need to design the qualification system as we design the engineering system. So qualification system cannot be designed at the end of the process, though we discussed it as the last step. The system need to be designed at the basic level. I mean, when we start the design of engineering system, the qualification system also need to be parallelly developed. That is, when we design a subsystem, we need to look at what is the requirement for that system, and then how do we test that system, and how do we validate that system, and then how do we do an acceptance test for that particular system. So we need to develop the procedure, we need to identify the resources, we need to identify the schedules, then along with the design of the system, and then this need to be used when we do the validation or verification or acceptance. So the design of the qualification system need to be done at the beginning of the design, or as we design the system, the qualification system also need to be designed along with that. And the exit criterion for integration and qualification is acceptance of the design by the stakeholders. So that is the exit criterion. So we can say that the system design is complete, or we can actually come out of that particular design process only when the stakeholder accept the system. And this one we discussed, explained again the last class, that these are the various validation procedures, and this is the verification and this is the acceptance test. So we do the acceptance test at this stage when the integration is complete, and we do the validation test at this stage, and parallelly we develop the qualification systems. In this, at this stage itself we develop the qualification system, and then verification is basically verifying the elements against the specifications designed. And operation validity, conceptual validity, requirements validity and design validity, all these need to be validated as we go ahead with the qualification process. So, before going to the qualification process, we will define few terms which will be interest to the qualification engineers or those who do the qualification test. So, the purpose of qualification is not only to find faults and failures, but also to prevent them and to provide comprehensive diagnosis about their location and cause. So, it is not only that we just identify the faults and failures, we need to ensure that we identify the source of these failures, as well as we provide some kind of inputs to the designers to ensure that such faults will not occur in the design. So, as we do the testing, we ensure that we can identify the faults and failures, and we can identify the location of the failures, as well we can actually suggest methods to prevent these failures also. So, if we identify the location, we can actually see from where what is the source of that error, and then once we know the source of the error, we can do a redesign of the system, so that such failures can be eliminated. So, the qualification engineers or those who are doing the verification or validation, so they have the responsibility to identify the sources as well as to help the designers to prevent such faults. We just recap the term normally we use when we discuss about the failures, that is the faults in the system. So, failure is basically a deviation in behavior between the system and its requirement. So, we have some behavior requirements in the system, and when the system is not providing that behavior, then we call that a failure. Error is a subset of the system state which may lead to a failure. So, a system state, whether it is the temperature, the pressure, or its processing time or the processing capability, any of these parameters which is a subset of the system state. So, this may actually cause to a failure. So, that is an error, and fault is the defects in the system that can cause an error. So, it is basically a fault in the system causes an error, and this error leads to the failure of the system. So, to have a successful qualification system, a number of complementary procedures to be employed. So, if you use one or two methods, that alone will not help you to identify all the faults. So, one procedure may identify the faults in the operational scenarios, another method may identify the faults in the internal systems or the interfaces. So, there is no single test which can actually identify all the faults in the system, and therefore, we need to identify different procedures or different testing procedures or verification procedures which are complementary, so that most of the faults can be identified. So, that is the requirement here. We need to have many tests or many procedures which are complementary to each other, which can identify most of the faults in the system, which can actually prevent the failures of the system. So, in order to do this, there are many methods employed by various system engineers and various system development methods, but it is the software community which actually put more comprehensive procedures and rules for testing of engineering systems, software systems, but some of these rules can actually be implemented or can be adopted for the engineering systems also. Basically, there are three laws in software testing or software qualification procedures. This can actually be used in the engineering system analysis also, because many of the procedures are common to software engineering as well as the system engineering. So, the first law is known as the pesticide paradox, which actually states that every method you use to prevent a bug, fault in the case of an engineering system. So, every method you use to prevent a fault leaves a residue of subtler faults. That means, whenever you use a particular method to prevent a fault, that actually brings in another fault in the system which cannot be identified using the present method. So, whenever you introduce a new method to prevent a fault, the faults associated with that new method cannot be identified at that stage. So, this is known as the pesticide paradox. So, you cannot actually ensure that by simply by removing one bug, you are actually eliminating all the bugs, because this the fault may come because of the new method also. That is the first law of software testing, which is known as the pesticide paradox. The second law is known as the complexity barrier. This actually states that the complexity of bugs or the faults grows to the limits of our ability to manage that complexity. So, as we are more and more capable of solving a complexity, then the complexity of the fault also will keep on increasing. So, that is known as the complexity barrier. The third law is that the code migrates to data. This actually states that the hardware and people migrate to software, which eventually migrate to data. So, initially if something is done by the hardware or something by the human, this actually will slowly migrate to the software. So, we will try to replace it with software, and then the software will replace it with the actual data. So, that is the code migrates to data. So, whenever we plan for engineering system qualification or testing, we need to ensure that these are the facts which actually limits our capability to do the testing. So, whenever we try to employ a new method of avoiding fault, that actually can bring another fault which cannot be identified by that method. So, we need to be careful while introducing a method to remove a fault. So, we should look at the importance of that fault, its frequency of the fault, then we decide whether to introduce another method to prevent that fault, because this new method can bring another fault which cannot be identified by that particular method. Similarly, the complexity of the fault also will keep on increasing as we are more capable of solving the problem, the complexity also keep on increasing. And then there is a migration of hardware, software, etc. to data. So, our algorithms or the methods should be capable of taking this into account when we do the testing of the engineering systems. Then again, when we do the verification of the system, so as we know, verification is one of the easiest stages in the qualification. So, we have verification, validation and acceptance. So, verification is one of the easiest method or easiest part of the qualification procedure. So, here again there are a few barriers, because verification is basically we look at the specification of the design and then see whether the actual system or the actual component meets that specification. But the problem here is that we can never be sure that the specifications are correct. So, the specification can be wrong. So, the specification whatever we made the specification need not be always correct, but we have to go assuming that the verifications are correct and do the testing verification test, but they need not be correct always. And no verification system can verify every correct program. So, there is no verification system which can verify every correct program. We need to have different procedures or different methods to do the verification of a complete program, or one method may not ensure that it is completely correct, and then we can never be certain that a verification system is correct. So, again there is no guarantee that the verification system is always correct. So, these are the barriers in verification, that is whenever we do a verification we actually have some assumptions and have some limitations. So, within that limitation only we are doing the verification. So, this shows that the confidence level of the verification engineer depending on to what extent he can assure that specifications are correct to the extent possible, and the system the most of the there are different complementary methods he uses to ensure that all the aspects of the system is tested or verified. And similarly, whether the verification system, how good is the verification system is. So, based on this confidence level only we can say that the verification is complete or the verification is up to the expectations of the design engineers. So, that is the barriers in verification. But then before we discuss about the methods, we need to define few terms about the fault categorization also. So, there are different kinds of faults happening in the system. So, some of the faults are very severe, some of them are not very severe, but some of them needs attention, some of them can be left as such because it may not cause any other problem in the system. So, the fault categorization is the first step in defining the importance of faults. So, if you want to categorize the fault in terms of the importance, so how important that particular fault is, we need to categorize them into various categories, and these categories define distinctions among the consequences of faults. So, the categories can actually give the distinction about the consequences of these faults. So, some of the categorization or the taxonomy of the faults are here. So, a mild fault is something which can actually be discarded, which actually say that we do not really need to look at that particular fault because it is a very mild one, like color is not proper, or there is not uniform surface finish, or there is a minor scratch on the system. So, these are known as the minor fault, which can actually be discarded because they do not create any further problem in the system. But then we have moderate faults which are unclear or misleading output or a wrong menu. So, once you give a input, it is giving a different output which is not related to the input you are giving, or the menus are not properly given. So, one menu is not leading to another one, or whatever required functions are not providing the menu. So, these are known as moderate faults. This actually may be a problem, but again we do not need to invest too much on this kind of moderate errors, moderate faults. There are annoying kind of faults which actually annoy the users. Basically he is looking for some data and he is getting some other data, or it is taking too long to process, or the menu is not properly coming, or it is not visible properly. So these are annoying kind of faults which need to be avoided, because the users may not like to have that kind of faults. But again, these are not going to create any major problem in the system performance, because the system may be performing, but it may not be performing as per the convenience of the user, or the user may not like to have that kind of faults, because that actually annoys him when he is using the system. So again, this need to be eliminated as much as possible. The next one is known as the disturbing kind of faults. So this actually will refuse legitimate transaction. So if you have a legitimate transaction, you have a proper authority to enter to that system and then carry out some transaction, then the system is not allowing you, it is giving some errors. So this is a kind of a disturbing fault, which again is not acceptable. Next level is serious faults, which actually loses the track of input outputs. So it actually does not know what actually transacted in the system, so what kind of inputs was given and what output was given, and that is something like in an ATM you deposited some money, it is not accounted into your account, or it does not know where the money has gone. So that kind of situation is a serious fault in the system. Then again, the next level is a very serious transaction, a very serious fault, which actually says that there can be mixing up of inputs and outputs. So a person deposits money into one account and that money goes to some other account, and money is withdrawn from his account because of someone else withdrew money. So this kind of mismatches of input output, and this is a very serious fault which need to be addressed at any cost. Then again, there are extreme faults, where actually these very serious faults are happening frequently. That is, that kind of situation is an extreme condition, where the frequent faults of very serious category. So very serious category faults are happening very frequently, then it is an extreme fault situation. Then there are intolerable faults, which actually causes long term unrecoverable data corruption. So this is actually intolerable, because it actually can cause the whole system over a period of time, the whole data may be corrupted, or they lose the track of what actually happened. So that kind of long term errors should not be there, and this intolerable kind of faults. And again, considering the seriousness of the issue, there are catastrophic faults, which actually the system shutdown causing data loss. So it actually causes data loss to the system, complete system, because it goes to shut down the whole system, and then a lot of data is lost without any trace of what happened. So that kind of situation is a catastrophic fault. And the last one is the infectious fault. Infectious fault is that it is not only that system, all the systems associated with that system is also getting corrupted. So this is a very serious situation, it is known as infectious fault. So based on the severity of these faults, we can actually classify them under various categories, starting from mild to catastrophic and infectious situations. So it is the duty of the qualification engineers to identify these faults and categorize them, what kind of a fault it is, whether it is a very mild one or it is an infectious one. So accordingly they need to look at the importance of these faults and then identify the required actions to be taken. So they need to look at the source of these errors and then find out or suggest to the design engineers the procedures or how to actually eliminate them. So if you can develop the methods and procedures to identify all these kinds of faults from mild to the infectious depending on the severity of the fault, and then try to eliminate them, that is the job of the qualification engineers. Basically qualification engineers will develop the procedures to identify all these faults and categorize them, and then report them to the design engineers, so that the design engineers can actually look at the system and then go for a redesign of the system. Again, for looking at the importance of the faults, we can actually find out the measure of importance depending on the frequency of the fault happening, as well as the severity of the situation or the environment at which these particular faults are happening. So a method of a quantitative measure of the importance of the fault type is given here, where I is the importance of the fault type and for the ith fault in jth scenario. So, Pij is the probability of the fault I to happen in a scenario j, and Cij is the cost of fault I in jth scenario in terms of rupees. So, if you can actually convert that cost of that particular fault, if it is a mild fault the cost will be less, but if it is a very severe fault then the cost will be very high. So, if you can actually convert that into rupees, then we can say that Cij is the cost of fault I in jth scenario, and Vj is the relative measure of importance of that scenario. So, if you have multiple scenarios in which the fault is happening, so we can actually give the relative measure of importance of scenario. Some scenarios may be very important, some may not be important. So, Vj gives the relative value of this importance. The actual importance of the fault type can be obtained as sigma j is equal to 1 to j Vj Pi j Cij. So, Pij is the probability, Cij is the cost, and Vj is the relative measure. So, if you have one particular fault happening under various scenarios, and if you know the cost of that particular fault as well as the probability of that fault as well as the measure of the importance of that scenario, we can find out what is the importance of that fault type. And this along with the fault taxonomy discussed earlier, we will be able to categorize this fault in terms of whether it is very severe, and then we need to look at procedures to eliminate them, or we can actually just leave it like that because it is not causing to cause any problem. So, this is the way how the faults are categorized, and then how do we do the analysis of the faults based on the probability of faults as well as the cost of fault and the importance of the scenarios. Now, let us look at the methods and procedures to do the qualification planning. So, as I mentioned, the qualification strategy need to be planned during the design stage itself. So, there are 4 major levels of qualification planning. One is the qualification process. You plan the qualification process, plan the qualification approaches, and you plan the qualification activities, and then plan specific tests. So, these are the 4 activities to be carried out in the qualification planning. As you know, the first one is the qualification process. This is the first level of design of the qualification plan, where we look at the various aspects of the qualification. Basically, we need to do the acceptance test, validation test, and verification test. In all these 4 stages, we look at these 3 tests to be carried out in the qualification, and we plan for these 3 tests in all the 4 stages what we discussed. So, this is the planning the qualification process. In planning the qualification process, we look at the system objectives. We identify what are the requirements identified in the system objectives. That is one of the earlier lectures we discussed how do we identify the system objectives, and then use these objectives to define the system requirements. As well, we look at the hierarchy of the objectives. So, in the qualification planning also we need to start with the system objectives. So, what actually the system supposed to achieve, and based on that only we will look at the objectives to be needed, and then these objectives become again a baseline for the qualification process also. So, we look at the system objectives, and then we identify the qualification system objectives. The system objective is more like a performance objective. So, based on the performance objective we look at the qualification system objective. So, they will be directly related because qualification system should actually ensure that the performance objectives are met, and therefore, the qualification objectives need to be developed from the system objectives. Then we need to look at the pass fail threshold for each test, because we need to conduct many tests like acceptance test, validation test, and verification test, and we need to look at what are the pass fail threshold for these tests. So, we cannot have a very low value for the threshold. So, if you put a very low value for the threshold, then the test becomes not really useful. But if you put a very high threshold, then what happens is that you may find that most of the tests the system will not be able to pass the test also. So, one of the main requirement here is to look at the objectives, the system objectives, and the qualification objectives, and then decide about a value for this threshold, the pass fail threshold for each and every test to be conducted. And then based on that we go for the qualification requirements. Like any other system design process, we look at the requirements of the qualification, and then the functional architecture for the qualification, what are the functions need to be provided, what are the top level functions and what sub level functions are needed. And then we go for the physical architecture development, and then identify risks and mitigation strategies. So, what are the risks involved in these processes and how do we actually overcome these risks, and then create a master qualification plan. So, at the end of the qualification planning process, we will be getting a qualification plan which can actually be employed for the throughout the design. So, initially by looking at the system objectives, we will develop the qualification objectives, and then based on the qualification objectives we will decide about the threshold values for different tests, and then we identify the qualification requirements, and from there we look at the functional and physical architecture, and finally we will be getting the qualification plan, that is a master qualification plan document, and this document will be the master document for all kinds of qualification activities. So, that is the first function in the qualification planning, plan the qualification process. The next one is planning the qualification approaches, and again this has to be done for all the three kinds of test: acceptance, validation and verification. So, here in the approach we will try to identify the resources and organizations, then assign the qualification activities to organizations, assign qualification activities to resources, and develop qualification schedules consistent with the development schedules. So, this is the planning the qualification approach. So, here we try to identify all the resources needed for qualification. So, we need to carry out various tests, and for these various tests we need to have various resources, and we need to identify the infrastructure available or the people who are capable of doing these tests. If the test can be done in house, we can actually identify. If some equipment to be procured, that can be planned, or there are some standard testing facilities available where the test can be carried out, so that also need to be planned. So, that is the first stage, you identify the organizations and activities and assign these activities to various resources, and then develop the schedules consistent with the development schedule. So, here we will be having various schedule for the design activity. As we plan for the design, we have the component level design and then subsystem level design, and so along with that inconsistent with those schedules we need to have the qualification schedule also. For example, if you want to verify the components, so when a particular component is made available as per the schedule, then the qualification schedule also should match with that component, and similarly when that component is going for an integration, the verification of that integrated subsystem need to be carried out when the subsystem is ready. So, the schedule whatever we develop for qualification should be consistent with the design activities, and this is to be ensured in the qualification approach development or planning the qualification approach. So, these are the various activities carried out in the qualification approach. The next one is planning the activities actually. So, how do we actually carry out these activities? So, develop detailed and derived qualification requirements, write actively level qualification plans and assign qualification responsibilities. So, these are actually planning the real activities. So, we find out the detailed and derived qualification requirements. So, there may be different requirements from the main requirement, there may be some derived requirements. So, we go into the details. So, in the third level we go into the details, we look at the individual items, configuration items and components, and then identify the detailed plans for each component. So, if you have a particular component identified in the design, we have to look at what is that particular component and what kind of requirements are there for this component, whether we need to have any specific or specialized fixtures to assemble it and then do the testing, or any specialized features are needed or specialized facilities are needed for that particular component. So, that kind of detailed planning will be done in the third function, which is the qualification activity. So, for each component and subsystem we look for the details and then develop the qualification activities. And the fourth one is basically the specific test. So, if you have any requirement of any specific test like simulation data, suppose some test may require some simulation data which cannot be, when the subsystem is available we want to test it for a particular function, then you may not be having the complete system at that stage. So, we may have to get some simulated data and feed this data to the system and find its output. So, this kind of specific test need to be planned in the initial stage itself. So, not in every cases, but there may be special cases where we need to have simulated models or simulated data to do the complete testing. So, that also need to be carried out in the initial planning stage itself. So, here we identify the required simulation data for each activity, create test scenarios, write test procedures, write analysis procedures and define test and analysis schedules. Again going into the finer details of a particular test we will do in the specific test activities planning. So these are the 4 activities to be carried out in the qualification planning, that is you plan for the qualification process and then plan the qualification approach, then plan the qualification activities and then plan the specific test. So these are the 4 activities to be planned in the qualification planning. So if you look at the IDEF0 diagram for the same process, you can see that these are the inputs going to the system, that the allocated architecture requirement changes. Then we have other inputs and these functions, we have 1, 2, 3, 4, 5, 6 functions in the qualification system design, and finally you will be getting the system qualification documentation. I will show you a better picture over here. So you can see here, so this is the first function where we define the qualification system design, and then we develop the functional architecture of qualification system, and then we go for the physical architecture development, and then go for the allocated architecture of qualification system, and then the interfaces of qualification system, and then we go for the define models for qualification. So in this case this is the additional function we provide, these are the common to the any system design, but here we have some system models for qualification. So we need to develop some models which actually represent different situations like environmental situation or the operating situation. So that kind of models also will be developed for qualification. So finally the outcome will be the design document, the system qualification documentation. So this is the output from this design process, and then the system models of environment, external systems and test equipment. So this also will be an output of the process of developing the qualification system. So these are the various functions involved in developing the qualification system. Let us look at some of the methods for qualification. There are various methods we can employ, that is various tests, it is a verification test or acceptance test or validation test. We can actually go for these methods of qualification methods. So basically we can say there are 4 methods, one is the inspection, and the other one is analysis and simulation, then instrumented testing and then demonstration. So we have 4 methods of testing or 4 qualification methods, and the first one, inspection, is basically used for physical human verification of a specific process or requirement. So that is a very simple and straightforward qualification method, which is the inspection. It is normally a physical or human verification. So we will look at the object or we do some kind of manual testing to find out whether there is any fault. That is the first method, and because of the increased use of automation, most of these tests are becoming instrumented test or automated test. So the human intervention is decreasing almost to a stage where we do not really need to have any human testing, because most of the tests can be automated. So that is the inspection scenario at present. So the inspection is basically looking at for the faults which can be easily identified either by observation or through some automated procedures like visual testing or using camera trying to identify the errors, or doing some simple test using instrumented test facilities. That set of methods are the inspection method, which is for the simplest of qualification methods. The next one is analysis and simulation. So in this kind of method we normally go for models to depict the real systems and their working. So when the system is not available, so we will try to do it in the beginning at the initial stages, we try to make a mathematical model or a physical model and then do the testing to ensure that actually it will perform as per the requirement. That is the analysis and simulation way of qualification. The key aspects of system are tested on models, that is examine the performance of a system in a range of environmental conditions. So it is difficult to do the actual testing in that are various scenarios like high temperature or high pressure or other situations like presence of water or presence of humidity, humid air. So these situations cannot be tested always in many situations. So we can develop models and then predict the performance of the system using these models. That is the modeling and simulation methods, and then these models initially help in comparing various physical architectures. So when you have various physical architectures, basically these models will help us to compare their performance even before they are built. and in verification validation stage they predict the results of instrumented test and demos. So they can be used for predicting the test output also. So if you have a model, we can actually predict what will be the output of an instrumented test, because we know the procedure for instrumented test and what we are trying to test in the during the instrumented test. So we can use the model and then predict the output of the model using this. That is the advantage of using a analysis and simulation methods, and here the cost involved is very limited, because we will not be going for always, most of the times we will be going for the soft models, and only in very rare cases we go for the real physical prototypes to do the testing, but otherwise it will be more like modeling and then simulation of the system and then trying to find out the faults of the system. The third one is demonstration. So demonstrate the system in front of unbiased reviewers in expected system environment. That is the method, qualification method, demonstration, where we do the demonstration of the actual system in front of unbiased reviewers. So we will not be having the real users. What we will do, we will take some reviewers who are not biased to a particular system. So we demonstrate this system and then try to find out their response in terms of the acceptance or in terms of the validity of the system. So that is the third method of demonstration, and this is primarily used for validation and acceptance testing only. So verification stage you cannot really have it, because verification has to be done by the designers, but validation and acceptance test we can use the real system and then demonstrate it to the biased reviewers and get their feedback about the system performance, as well as we can find out the faults with the system from the customer point of view. So these are the four methods of testing, that is inspection, analysis and simulation, and instrumented testing and demonstration. So we have inspection, which is inspection by a human operator, then we can have analysis and simulation, then we have instrumented testing where we do testing using instrumentation or standard test as per the standards, and then we go for the demonstration of the real product. So these are the four methods of qualification. These are actually explained here with more details. So we have the inspection, which will compare the system attributes to requirements, and here these are all segments of verification and validation can be done using this method of inspection, basically for human examination, and here the success and failure can be judged by the humans. That is the inspection method. And analysis and simulation, here we use the models that represent some or all aspects of the system, and then throughout the qualification we can use this method more during early verification and acceptance used with demonstrations. So that is the application, it is used for early stages, and here the physical elements are not available because what we are having is more of a model, and then instrumented testing is expensive. Under that situation we can always go for an analysis and simulation, and then demos not enough. When the demos are not enough, we can go for analysis and simulation. So they are most effective under these situations where physical elements are not available or instrumented testing is very expensive and demos are not enough. So we can go for the analysis and simulation method under this situation. And instrumented testing is used with the calibrated instruments. We use calibrated instruments for doing the instrumented testing, and they can be used for verification testing, and it is most effective when the engineering test models are available. When you have the actual models available, we can use the instrumented testing, and when detailed info required to trace failures. So if you want to trace the failures and we want detailed information, then we can go for the instrumented testing, and then life and reliability data needed for analysis and simulation. So when you want this reliability data, then also we can go for this. Then the last one is demonstration, so which is basically demonstrating the product in front of the viewers, and this is most effective when we have the final product, and it can be used for validation and as well as acceptance procedures. So these are the four methods which are normally used for qualification of systems. Now let us look at what are the testing methods. So we mentioned that testing is one of the most important qualification method. So there are different types of tests to be carried out on a system, because the system has to be has to perform under various situations. It need to have various test requirements. So the system need to satisfy these requirements, and therefore we need to do various tests. It is not a single test which will give you all the output. So we need to do the test under various situations, under various tests need to be carried out. So some of these tests are actually functional tests. Basically the functional tests are to examine the input and output under mostly nominal condition. So here what we try to do is we give the known inputs to the system and try to find out the output and to see whether it is functioning normally. So the functional tester basically we look at the input and output, and it will not look into the details of how the output is coming. If the output is not coming, it will not tell you from why it is not coming. So functional test is basically to look at the functioning of the system, whether the input a particular input is giving an output, the required output. So the test planner need to identify what are the inputs to be given to test the functioning. So various inputs will give you various outputs, and under various situations you will be giving various inputs. So the planner need to identify all the inputs required to test that particular function and then get the output from this. So this kind of test is sometimes known as black box testing also, because in black box testing we do not look at the details of what is inside, we will give an input and get an output. So that is the functional test. A structural test basically examines the structure of the system and its proper functioning. So basically looking at the physical structure of the system, whether it is reliable, whether it can take the load, whether it can withstand the temperature. So these kind of features are tested in the structural test. Then we have the performance test, particular attention to extreme environments in structural test. So this structural test, actually we have these 4 tests which are basically part of the structural test. When we do a structural test, we look at the performance test, we look at the recovery test, we look at the interface test, and we look at the stress testing also. These 4 tests are part of the structural testing. So we look at the performance under various environments, we look at the failure modes created and system's ability to return to operating mode, that also tested in the recovery test. And then we do the interface testing, we examine all interface conditions, and then we do the stress testing where above normal loads are placed to see systems performance and get systems breaking point. So these are the 4 tests which are conducted under the structural testing. So the basic tests are functional test and structural test, and in structural test we go for the performance evaluation, the failure recovery analysis, interfaces, and stress testing to see whether it can actually take the load or above normal loads, which can whether the system can withstand such loads. So these are the 4 methods coming under structural test, and the functional and structural test are the 2 testing methods normally employed. Apart from this test, to test basically structural and functional, Samson has defined testing facets, that is you need to have different phases of testing. It is not only that you do a structural or functional test, we need to look at the various phases of test to be carried out, and then he classified them as structural, functional, then environmental and conditional. So what it says that system implementation is looked at the structural definition, and then function related is connected to the system function. Environment is basically the environment and conditions related to requirement characteristics. So these 2 are actually to be tested, the environmental and conditional need to be tested under both the conditions. When you do a structural test, we need to look at the environmental aspects as well as conditional aspects for all these tests. When you do a compliance test for under structural test or an external testing or the operations test, we need to look at the environment, what kind of an environment this particular operation is carried out, whether it is a computer controlled or it is a manual one, or it is a prototype we are doing, or it is a simulator. So what is the environment under which this particular structural test is carried out to be looked at. Similarly the conditional also, what kind of accuracy is needed for that particular test, what kind of load is there, what kind of logic, size, timing. So this environmental and conditional facets are to be added to all these tests under structural and functional. That is the testing facets to be identified when we do the testing of the system. And these are the black box and white box testing. I mentioned about the black box testing. We said that the outputs are determined correct or incorrect based on inputs, and inner workings of the module are ignored. So this in black box testing we do not really look at the inner modules, we look at only the input and output. And in white box testing we look at the inner workings of the module and look at what is actually the problem. So usually used at the configuration items level of testing, and it is impractical at the system level. So this black box testing is used more at the system level, and white box testing is used at the component level or the configuration item level, because the inner workings of the module can be examined in the white box testing, which is difficult in the black box testing. So whenever do your testing, We have to see whether we have to do a black box testing or a white box testing, and accordingly we will plan for the particular test. Okay, the next one is acceptance testing. Probably we will discuss about this acceptance testing in the next lecture. So, whatever we discussed today is basically looking at the qualification methods and what kind of planning we need to do, what are the procedures to do the qualification testing, and how do we identify the various tests to be conducted, and what are the qualification methods to be employed, and qualification methods to be employed for testing the system. So, basically we were looking at the verification and validation of the system, and then we need to go for the acceptance of the system. So, verification and validation, there are various tests to be conducted, and this test can be classified under various categories, and depending on the fault also we can identify the fault category and then decide about the testing procedures. That is all what we discussed today, and in the next class we look at the acceptance procedures. How do we ensure that the acceptance tests are sufficient to meet the customer requirements? That we will be discussing in the next class. So, till then, goodbye.